Welcome to a forthright audio podcast of last week's newspaper column, inspired by spending 2 days at the Pacific Northwest Direct Seed Association spring event held in Colton, Washington. Water vapor is the most important greenhouse gas in the atmosphere, and we ignore it because we think we don't affect it. Unlike carbon emissions that we can easily measure in a carbon cycle where we monitor our contribution, the most important elements of the water cycle are in the soil. 2 days spent with internationally acclaimed soil scientists made it impossible to ever look at a fallow field the same way again. Here's the column titled Drought Resilience Requires Roots, as published Thursday, June 20th, 2024 in the Spokesman Review. With a disaster declaration in place for Washington, a presentation on the Pacific Northwest Direct Seed Association agenda titled Drought Proof Your Ranch was timely. Driving south to Colton, it didn't look like a drought, with multiple shades of green covering rolling crop fields. Bare soil and fallow fields added contrast, waiting for moisture for a fall planting. Spring thunderstorms obligingly provided rain. It's the conventional pattern for the Palouse, where farmers are gradually shifting to a model of direct seeding into stubble left in place after harvest. And according to soil scientist Ray Archuleta, in fallow fields, quote, the soil is naked, hungry, thirsty, and running a fever, end quote. Naked soil lacks living roots and protective cover. Hungry soil microbes need living roots to deliver their food. Soil without living roots and healthy microbial populations have less ability to hold water. And naked, hungry, thirsty soils create heat islands, adding to localized and general warming that can affect rainfall patterns and climate. It's as true for small irrigated urban yards as it is for acres of dryland agricultural ground. Archuleta was a featured speaker at the 2024 Soil Health event in Colton this week. He reminded the farmers and ranchers this wasn't about replacing conventional practices with organic farming. Quote, we destroyed the planet under an organic farming system in 1935, he said. The destruction began with the theory that breaking open the sod of the tallgrass prairies would allow the soil to better absorb the rain. It was politically expedient pseudoscience, justifying government agents planning expansion and infrastructure developers who saw money to be made, until blown away by the Dust Bowl of the 1930s. But rain does follow forest and grasslands, where the soil is filled with the roots of a diverse ecosystem. Rain falling on bare soil beads up and runs off, like pouring water over a cup of flour. When rain falls on healthy living soil, it infiltrates like spilled water sucked into a piece of bread. Unhealthy soil lacks the voids necessary for rainfall to be effectively absorbed into and be available for plants to see them through drought. Focusing on healthy soil was the key for guest speaker Alejandro Carrillo in transforming the 30,000-acre Las Damas Ranch in Chihuahua, Mexico. It's not about how much rain falls, Carrillo said, it's about how much infiltrates. His ranch supports cattle at a stocking rate 4 times higher than his neighbors. What used to be tallgrass prairie when the Spanish priests recorded their first impression of the landscape around Las Damas is now classified as desert. Yet Carrillo's cattle and donkeys graze year-round despite drought, after a decade of adaptive ranching has regenerated the ecosystem. His greener pastures receive more effective rain and more inches of rain than other ranches in the area because the cooler surface temperature of the covered ground drops the dew point. Cooler air retains less moisture. The key is plant biodiversity. Australian soil scientist Christine Jones emphasized the complex and mutually beneficial interactions between root exudates, soil microbes, fungi, and bacteria. Jones and Archuleta called root exudates liquid sun, their secretions resulting from plants collecting solar energy and converting it into plant food. Living plants feed the soil biology, which provides minerals in a complex market-like exchange of minerals and ecosystem services. Quote, most of the scientific research has been focused on inputs rather than life in the soil, Jones said. She confidently said, quote, 98% of warming since the Industrial Revolution is due to water vapor because of poor soil infiltration, end quote. Microbial diversity is also essential to retaining carbon in the soil. NASA's website describes water vapor as the most abundant greenhouse gas, but only gives it credit for about 50% of observed warming, and does not acknowledge the role of soil health in carbon sequestration. The scientific debate continues. There was irony in having this discussion in a barn set in vast monoculture fields of wheat and occasionally canola, whether it was planted by direct seeding or into bare ground. A healthy soil ecosystem requires living roots year-round, supporting plants from different biological families, each feeding different microbial populations with different functions. It's the concept behind the use of cover crops as part of the rotation to reduce bare soil exposure to water and wind erosion and to increase soil vitality. Having only one kind of plant, whether a field of wheat or a lawn of bluegrass, means a lack of diversity in the soil biology. The pore spaces in the soil necessary to effectively absorb water shrivel, whether from rainfall or a lawn sprinkler. Expecting compacted soil to soak up the rain is like trying to use a dried up kitchen sponge left out in hot weather to wipe up a spill. Archuleta emphasized the necessity of on-farm test plots in biodiversity and the boldness it takes to risk your income. Keep the status quo and you can blame the weather. Experiment and fail and it's all on you. Doug Poole was one of 3 dryland farmers who shared lessons learned. Poole has successfully, and sometimes unsuccessfully, incorporated cover crops into his dryland operation in north central Washington. When asked what he'd like urban audiences to know about regenerative ag, he said, "Tell them we're trying." That was the column, and all the speakers were very much pushing that the farmers have got to figure out what works on their particular land, and that they may need to use some pesticides and some herbicides in spot places, but to know why they're using them, and to know that because they've actually tested the soil, they're monitoring the soil biology, and they're treating it as a whole ecosystem. Organic isn't a panacea. Many of the organic products that we see in the stores are grown using extractive processes. They just avoid certain chemicals. Responsible commercial farmers, organic or not, want their operations to be sustainable both financially and environmentally. They are trying. Hanging out with people digging deep into the soil for the last 2 decades has meant that I see the climate change debate with a completely different lens than usually is discussed in the media. And we often hear science writers expound on how little we know of what goes on in the depths of the ocean. We know even less about the soil microbiome, about how plants communicate with each other, about this complex ecosystem where roots and fungi and bacteria and worms and insects interact in ways we're just beginning to understand, and how they are affected by changes in human use of the land, whether that's more tillage or excluding grazing impact to recycle nutrients into the soil, or chemical applications, or when we harden the surface with buildings, paving, and other structures, or when we take the soil completely out of play with industrial energy facilities, including drilling, mining, wind turbines, and industrial scale solar. What we can see above the skin of the earth is the desertification resulting from thousands of years and sometimes merely decades of human actions taken in ignorance of this ecosystem. We can see the impact of unhealthy soils, reducing the nutrient density of our foods, and the resulting impact on human health. We need major changes to make agriculture regenerative instead of extractive. Continuing to plow money into massive decarbonization projects, if the problem is water vapor, is a waste of resources and a missed opportunity to mitigate anthropogenic climate impact. It would mean we are rearranging deck chairs on the Titanic while the iceberg is getting closer every year. We need to be having a more honest conversation about what really are the drivers and what are the lagging indicators of changes in climate. As always, reference links are included on the Substack post to this week's background reading. You're invited to subscribe for notifications of new content on a variety of regional topics with or without a pledge, and thank you for listening.